Hello dear colleagues, my name is Mikhail Popov and my colleague Rami. We are scientists at the Research Institute of Sweden, and this presentation is about our project and results for drone and AI assisted livestock monitoring. This problem has been brought to us by Swedish farmers, which formulated it as they do spend some hours each day to go around and look for animals and collect them back to the barn. So they asked us, is there anything we can do about this problem? And we went to the farm, and this is an actual build from the farm where we did all eventual filming. This is beautiful Highland cows. And started to think what we can do about it. So essentially, there are two ways you can solve this problem. So you either use sensors, the IoT, Internet of Things, and you place them on each animal. And this will require GPS placed in each sensor. This will require battery, which you need to maintain and change regularly. And you will need wireless coverage to connect all this network over the whole area, which is not always available in the rural areas. Another issue with the IoT solution is scalability, because as soon as you have many cows, many animals, like hundreds, so probably you will spend a substantial portion of time on changing batteries at the IoT devices. So we have eventually chosen to opt for a drone, because drone is flexible. It can work with any animals, even wild animals, who definitely will not have any GPS necklaces. And in the current situation, of course, the drones will require operator, and it will require in many cases to follow the regulations. But it was an interesting solution to test and to see whether we can use the drones and whether we can use the algorithms to find the animal and report its location to the farmer. So the idea was simple, essentially. So the vision is that we have a drone, we press a button, it flies around, finds itself the animal you look for, and sends the coordinate to some end user device, a telephone, for example, to the farmer. The first question we needed an answer for was that whether we get sufficient picture quality from the drone so we can distinguish, separate animals, and potentially can teach the algorithm to do the same. And we can see from this picture, and I hope that with all the conversion, the quality is still good, that you can clearly and crisply distinguish between different animals, even the small one, and in the original video, at least you can see the horns and all the tiny details you need. So this gave us quite a bit of confidence that when we apply the algorithm, it will repeat the same work done by the human eye and the human brain, so that they can also distinguish between animals and the terrain. As we could see on the previous picture, so in the open terrain, you could clearly see the animals in the open landscape. So the next question was whether we can see the animals and distinguish the animals behind the trees. And as we know, it's difficult because they are hidden behind branches and leaves. So we thought that using an infrared camera as a complement to the RGB camera can bring us a lot of information and help us solve this problem. So we did this test. We ran 2 cameras in parallel on the drone. And you can see that we actually received mixed results. It's the same picture, but it's in the visible light on the left-hand side, and it's in the infrared light on the right-hand side. And we can clearly see that the infrared picture helps us to find an animal. It's in the white circle, which is very difficult to find on the regular image. On the other hand, we cannot see on the infrared image the animal in the red circle, which is clearly seen on the visible light image. So in this sense, we can see that it actually cannot substitute, in general, the RGB picture, because sometimes it doesn't work very well. Another interesting case when it was difficult to use the infrared camera, it was warm weather. So the day we filmed was very warm. It was beyond over 25 Celsius. And what essentially we saw on the ground, and the ground, sometimes it was colder and sometimes it was warmer than the temperature of the cow. And the result of it was that we can hardly see anything in the infrared picture. It's again on the left and on the right hand side. There are 2 synchronized pictures, and one is in the visible light and another one is in the infrared light. The next step was to choose an algorithm for object detection and localization. And we have chosen an open source algorithm called Faster RCNN, which essentially works as follows. It scans the taken image with frames of different size and converts those into vectors, where vectors are matched against the library, whether it's, for example, a dog or a cow. And these images are scanned through the whole current picture and looking for a best fit, and the best fit of a specific concrete animal will give us a location of the animal. So essentially the result of this algorithm is a box and a label. The box surrounds the animal and the label tells us what kind of animal it is. The algorithm was pre-trained on a number of objects, and we have just uptrained it. This method is called transfer learning. For uptraining the algorithm, so we used an open source tool again. So essentially what we did, we draw by hand a rectangle over each animal, in our case cow, we saw in the picture. It was very time consuming, and we eventually annotated, this is the name of the process, 713 RGB images. Part of these annotated images have been used to uptrain the algorithm, and part of these images have been used to test the performance of the algorithm. This uptraining was required to improve the performance algorithm of the specific animals of interest, and in our case these were Highland cows, which were at that farm we were filming at. It's worth mentioning that of 700 annotated images, we used roughly 500 for uptraining the algorithm, and then the rest, 200 roughly, we used for tests to determine the performance of the algorithm. Furthermore, we had to reduce the original resolution of the pictures we had a few times due to hardware limitations. Nevertheless, we have achieved very good results. So the algorithm has found on average 9 cows, 9 animals on the pictures of 10, which corresponds to the recall of around 90%. The precision of, in our case, 82%, tells us that of all objects found by the algorithm, only 80% were the animals of interest, in our case cows. The rest were something else. It is, however, from the perspective of the task we were given, it's less important. So if it's a false alarm, so it's a false alarm. It's more crucial here is to not miss animals. So in this case, the recall metrics is more important. And here is a very important aspect of using machine learning AI in these tasks. Well, when we annotated images, it was sometimes very difficult to find the animals behind the trees. And after we have made the test, we have discovered that, at least in one case, the algorithm has found a cow, which we missed. So the ground truth, our labeling result, is on the right-hand side, and the animals found by the algorithm is on the left-hand side. And essentially, you can find that animal which we missed if you look very, very carefully. The key takeaway here is that when we try to keep track on animals in behind the trees, on any other difficult situation, we get tired, but the algorithm does not. So this is a good argument for using the algorithm to help assist us in, for example, finding animals in difficult terrains, just simply because it can work without getting tired. In our project, we didn't make a complete system. So essentially, we flew the drone, we recorded the images on a SIM card, downloaded the images, and made an offline processing. But the next question is, if we are now about to build a real system, how do we do that? Essentially, it means, do we need to process images in the cloud, on the ground, or should we process the images on the drone? And the answer to that we should process the images on the drone, because in the opposite case, if you would like to process them on the ground, in the cloud, you need to send high quality, high resolution images over a radio channel, which might not have the capacity of doing so. If, however, you choose to process the images on the drone, which we call the Edge AI, then the only information you need to send is just a couple of numbers, which is essentially the longitude and the latitude of the position of the animals. And that's a huge difference between the two amount of information you're about to send. Further, we have seen that the infrared images, they can complement the information we are missing. However, we saw that it adds information, but probably not to that extent as we expected. An important aspect of using or not using the infrared cameras is its cost, because if we think about building a commercial system, the ER infrared camera is few or probably many times more expensive than the RGB camera. So it will substantially make your product, your design, more expensive. And that's something we would like to avoid when it comes to, say, consumer products like the products for farmers. So last but not least, I think it's important to discuss what else are we missing in the drone. I'm going to launch a small video here. So the point here is that it makes a lot of noise. And as we have seen ourselves, that to a certain extent scares animals, and they can run away just because of the drone, and we would like to avoid it. Another outstanding point about the drone is that it requires an operator. So eventually it will be very nice to automate this process so the drone can at least fly by itself. And it actually can be simpler than the thing. So in a farm, you can essentially program a drone just to fly around the farm following a certain path, and that will be enough in the first place. The next point for concerning the drones is an easy command. It essentially means that we should be, say, have a very simple way to tell the drone what to do. So probably even the voice command. So essentially the farmers who don't need to have, say, a special degree in computer science to control the drone or be an operator of the drone, so they should be able just to press the button and send the drone away. Last but not least here is an affordable business model, and it's very closely related to the design of the drone. It should be originally made affordable, so it can be used in the applications which are cost sensitive. That's more or less it, and I hope that I will also be able to answer your questions offline if you have any. Here are my contact details. Thank you for your attention and have a nice day.